All right, guys. I would suggest then we start. If there is any question during the presentation, please just raise your hand. I'm very open to lead an open discussion. Once I'm done with a couple slides we've prepared here, we can go ahead immediately and have a Q&A session. I guess why you came here because you're interested in stacking and equipment. So today's topic is how we as an organization have overcome a bottleneck of stacking within battery equipment. But let me first start with my introduction. So my name is Viktor Poc, and I'm responsible as a head of sales and business development in Muhlbauer Group. What does that mean? I'm responsible for all the battery-related topics, including battery cell assembly, battery management systems, and even fuel cell equipment, which is in certain areas quite similar to the battery one. So I'm located in Germany at our headquarters in Bavaria, in Roding. So anybody from around, please let me know if you're interested, and I would be more than happy to host you. All right, that's for the introduction. So what we're going to talk about here today, wait, does it work? There it comes. So I want to recap on what we talked about before. If you are not familiar with Muhlbauer, what we do, where do we come from, and what's our main advantages in terms of battery, or I would say in general, equipment manufacturing. Then since, I mean, we've been in partnership with Volta for basically almost from their start. So I know it's supposed to be, and I want to talk about technical stuff, and I want to talk about some stacking methods we've came across. I want to talk about some challenges which we faced over the course of developing that stacking equipment which we have today. And of course, I want to compare. I want to compare our stacking solution. I want to compare the market stacking solution. Here, I'm always open to suggestions, comments, and I always say to anybody I speak about stacking that we appreciate a lot when we get market feedback, right? So I've been with the company since basically touch-based any battery-related topics. So yeah, that's what I also found important to mention. All right, what is Muhlbauer, who we are? So let me start with the picture. This is our headquarters in Germany, in Roding, which is located in northeast from Munich. It's in the middle of Bavarian forest, so not much around. So it's about 1.5 kilometer long street where most of the magic from which comes from us happens. So from the beginning of the street, we have our parts and system manufacturing, which is one of the 4 divisions, and then when you continue, these U-shaped buildings are our R&D assembly competence center. Currently, we have about 5,000 employees worldwide. So yes, we are a well-established equipment supplier. We've been established in 1981 by Mr. Joseph Muhlbauer, who is still a very active part of our organization, acting as a chairman of the supervisory board. What I really want to emphasize and mention here, since there is a lot of news, also negative news on the market about European equipment manufacturers, that their situation last year wasn't too good, I would say. We are 100% financially healthy. We do not have any debt capital, and all the investment which we are making is coming from our own. So we are very strongly committed to the battery market. And we are basically creating a option for the market to go for equipment from Western world, from Germany. So basically, as an alternative to the current leaders coming from Asia. Yeah, I mean, in the picture you can see also our North American facility. We have more than 40 sites worldwide. However, what is very important to mention, our core R&D related to batteries and related to e-mobility is based in Germany and in Slovakia, which is our second biggest hub with 700 people. So we try to concentrate that in Europe. All right, just that you have the complete picture. We got 4 business lines at Muhlbauer Group. First, parts and systems, absolutely crucial for our topic today. Maybe just a side information, actually, I'm just on a business trip here in US, yesterday I've been asked on a meeting that how we've been able to do all that in 4.5 years, all what we're going to talk about today. And parts and system division is one of the main reasons. Simply said, we manufacture all of our equipment in-house. That means any mechanical part which is coming to our machines is manufactured literally couple buildings in the front from our R&D center. So when we've been working on stacking solutions, stacking development, you can imagine there's been a lot of challenges, a lot of changes which we needed to do. Basically, after our engineering releases anything in the production, we are able to have it by morning on the shop floor. So absolutely crucial part of our business. Automation business line is basically all the off-the-shelf equipment which we are doing. We are market leading in semiconductors, RFID, and also smart cards. So basically, if you're located here in the US, which I assume the most of you, if you pull out your credit card, there is almost 100% chance it's going to be produced on Muhlbauer machines. So we are market leader in this industry as well. If you have one of those fancy metal cards, that's 100% Muhlbauer machine. Security is the government business which we do, which is related mainly to smart cards. So we do produce ID documents, passports for various governments around the world, and we provide basically turnkey solution for or their production. And now coming to the most important part, which is MBA Tech, which is our latest 4th division, which is all related to e-mobility, mainly batteries. So what did we do in this industry? We have decided to open a division, separate division as of last year, but we've been working in the industry for about 5 years. So what we have done here, we have basically taken our core competencies from the off-the-shelf industries which we operate in, semiconductor, RFID, and we combined them into a solution for battery industry about 5 years ago. Since then, Muhlbauer Group developed and built multiple turnkey solutions for prismatic cell assembly lines, pouch cell assembly lines, including a full automated, first of its kind, lithium metal line for North American market. So at this point of moment, we have in our portfolio solutions for lab lines. So basically, any battery manufacturer is able to come to Muhlbauer and take a lab solution. Mainly, we talk about tabletop or semi-automated solutions for cell assembly. So starting from notching, finishing up with filling. Of course, the second step, very natural, is always a pilot line, which we, in this case, consider a fully automated cell assembly line with an automated workpiece carrier system, where basically the operator's intervention are required only to exchange basically materials. All the quality control, all the processes are being done automated. This is basically a line which matches B, but more C sample production. These lines can go up to around 6 ppm, so parts per minute. And then, of course, the superior goal is a gigafactory supply, which, as I mentioned before, you've seen it on the picture. We are really one of the few companies in Western world who has the power and the capability to scale battery manufacturers into gigafactory. And we are proud also to say that we are the only European manufacturer who actually built a full gigafactory for prismatic cell assembly. So this is a very short recap on what we do. I want to emphasize one more time, because I recall last time there was a question popping up. So we start once the electrodes are on a reel. We have solutions for notching, stacking, and basically complete packaging part, whether it's prismatic or pouch. All right. Of course, what is the core of this or the message which we want to give away is that whether you are a lab, pilot, or giga, we are always looking for a partnership. So nothing is able to happen and scale up without a very strong partnership. So we are there to support smaller companies on their path, growth path, and we are also ready to basically immediately supply gigafactory. So that is our philosophy, and that has been also our driver when we have committed to the market to support European and North American market to help them scale and provide a alternative solution to the Asian turnkey solutions. All right, so this is what we have been all waiting to talk about, is the stacking. So let me walk you through first, and this is what we have learned from the market over the past 5 years. This is what we have done, what we've been challenged with. So we distinguish at this point of moment between mainly 4 stacking types. So the majority of the market, mainly automotive, is taking a Z-folding type of stacking. Of course, some of the manufacturers, mainly because of depends performance, it can be because of the manufacturing simplification down through the packaging, can use laminated separator within stacking. This comes mainly also from the next generation of battery cells. So if you talk about some solid state with a little wetting, or semi-solid state, or even all solid state, of course, depends. They try to also stack often a mono cell, so there is a pre-laminated electrodes together with the separator, or of course then there is a possibility to wind the stack within a prismatic can. Yeah, and what I want to take a look at is some positives and some negatives. Each of the solutions have its own. So let's start with Z folding. As I mentioned, yes, it's the most common solution mainly for automotive. Of course, you don't need to use any glue. You can use cheap separator off the shelf supplied, and you are able to maintain cleanliness level on the electrode level before stacking. Of course, what is negative or challenge, I would say more, is that you need to make sure that your stack is fixed down the road, down the packaging path, and you need to be able to prevent any shiftage of the electrodes. If we come to the lamination, so basically laminating the separator onto the anode. Yes, it does stabilize the packaging part. However, there is a downside of using a glue, so more expensive separator usage is definitely required, and the process beforehand is much more complex. And those who has experience, yeah, you gotta avoid wrinkles. It's not easy. But then, of course, the stacking part itself is much easier since you are avoiding basically handling the separator. If it comes to the third, monocell simplifies the stacking. Of course, you stack only one type. So I'm not even sure if we should call it stacking anymore. But it's a very complex process. If we talk about the next generation, often manufacturers even require special vacuum usage, let's say, during the lamination procedures, or some unique requests. So yeah, it's a complex process, and it's yeah. Okay, then with regards to the last one, binding, well-established process on the market, mainly used in prismatic cells for energy storage, right? Of course, it's easy. You can go buy a binder for relatively inexpensive pricing, but you are reducing your active area, you're reducing your energy density over the cell. So yeah, it's easier from one side, it's well established, but you need to be willing to reduce your energy density once you bind. Which type is the best? I have no idea, to be honest. We have various solutions for more. But as we see the market today, and please anybody correct me if I'm wrong, but we intend to see the market going into the direction of Z folding mainly, as mentioned, mainly for automotive. So what I want to talk about today, and what was also the headline of this presentation, was the bottleneck of the stacking. So yes, a lot of you consider stacking as the most difficult part of the assembly process. I may be able to confirm that. Yes, it's a difficult process, and it has always been considered a bottleneck within the packaging part. So I want to talk today about some specific challenges which we've been facing. I want to take you through 3 generations of stacking, which we've developed over the course of 4.5 years. And basically what has been, or the learning curve for us, and the key takeaways from each generation. So the first stacker, which we've built, we started in 2020, we finished the R&D, and we have moved to the next gen somewhere in mid of 2022. Imagine German well-established equipment supplier getting into a battery equipment. It wasn't easy, but we had a huge advantage, which was we started with blank paper. So our engineering had really a lot of thinking to do, and that's why if you have a look at our stackers these days, they look different, and they even work different. So what has been the main challenges for us with the first stacker? Of course, we didn't know how the unwinding is going to work. The singulation, what's going to be the challenge to cut the electrodes, what type of cutting we are going to use. Is it going to be laser? Is it going to be mechanical? Are we going to be able to have the accurate stacking, right? So there are quite strict requirements on the market in terms of stack alignment. Yeah, we've been hearing before we've built our first stacker problems with vision and cleanness level. So So how advanced vision capabilities are we able to involve in the process? Of course, are we going to be able to handle the separator? That has always been a major challenge. So at the end, we came to develop a stacker which was having a performance of 0.2 per sheet per table. So this is how we are tending to always claim the speed of the stacker. So we are not talking about parts per minute. We are not talking about megawatt or gigawatt hours. We talk about a speed of sheet placement. So the outcomes of the developments and the learning which we have taken away was we've been able to pick and place. So we used the conventional pick and place technology for our stacker. We have integrated surface quality inspection methods, which was also a nuance to the market back then, where we had line scan camera systems, first generation of those. What we have witnessed or we didn't expect it to be that big of a challenge was separator handling, very honestly. That was difficult. So how to make sure you avoid any wrinkles, how to make sure you are not moving the electrodes with the separator. So yeah, that was a big challenge. So that's why we were not able to speed the stacker up from 0.7 second, which was back then somewhere the market value which you were able to get in Asia. Our stacker was relatively big. It was around 40 square meter. And honestly speaking, it was also relatively expensive for the market. So it was not usable for a gigafactory usage. However, it has provided us a huge amount of learning, which we've been able to utilize then in the second generation. So how we have taken the second generation, we said to ourselves, all right, let's build something innovative. Let's build something which is fast and which is able to be a gigafactory solution. And of course, at the end of the day, must be faster than the market standards to overcome that bottleneck of stacking being the slowest part of the cell assembly system. So what we have done, we've been able to improve the speed somewhere to about 0.5 seconds per sheet, or from 0.3 to 0.5, but I want to be very honest, very stable. We were at 0.5 seconds. We've been able to reduce the stack change, which is a huge part. And of course, we have used a new technology to basically perform the stacking. So what we have thought gonna be the biggest challenges is the stack stability. Why is that? With our second generation of stackers, we decided to use a rotary system to basically pick up the electrodes and place them on a stacking table. So we had a rotary drum for anode. We had a second rotary drum for cathode. So we thought, yeah, the stack stability will be a challenge since we've been moving the mass. By mass, I mean the stack itself at the bottom of the stacking table. We've been moving it from left to right, and we've been cross-cutting the separator along the way, which we thought is going to be a challenge. Of course, we wanted to, have a higher throughput, so that we considered it going to be a challenge. We wanted to reduce the footprint. And we knew from the first generation that the separator control will be a challenge. Now, as a result, out from that, we realized we have, with the increased speed and with moving the mass, we've witnessed a lot of vibrations at the very beginning, which we must have eliminated. And we succeeded in that, but it was a big challenge at the start. However, the biggest one was still, and I keep saying that, was the separate attention control, which especially in case when you are moving the stack from left to right was a very, very big challenge, since you can imagine in those high speeds, you need to keep the tension proper. Once you're on left side taking or placing the electrode, then you are moving, you need to loose it and again keep it tense when you are placing the other one. So it's been really tough time. However, we've been able to manage. We started to see first-time usage of alternative materials. So a lot of lightweight materials, magnesium, carbon fiber, in order to decrease the weight of the system and decrease mainly the weight of the axis, of course, which are moving. So the outcome in general of the second generation of the stacking was that we have resulted in a quite big machine. So it was a large system, since we still maintained our key competencies in there, which was a full line scan camera system. So checking the particles from top and bottom. We've had contact and contactless cleaning inside as well. So the system became big. It was fast, but we still thought it would be good to have a smaller system which is even a bit faster for a gigafactory usage. So we have concluded on developments on this stacker by mid of last year, and we have moved to our latest, we call it Gen 3 Cobra stacking solution. So the challenges, right? So I'm confident to say we've learned how to handle, how to stack, what to expect while we are building a stacker, a high volume stacker. So there were a bit different types of challenges to our R&D team these days. So the first was footprint, right? I mean, as we all know, dry rooms are very, very expensive. So I wanted to come as compact as possible. Second was, yeah, I mean, we are not naive. We are coming from Germany. We want to conquer the Western world with our equipment and the battery manufacturers. We need to be having the best cost performance ratio. So that's a big challenge. And the third one was, let's keep it simple, let's keep it simple and much faster, right? So we've been able to come down to a performance of 0.23 seconds per sheet per table. I'm mentioning all the numbers I'm mentioning are per table. We regularly use 2 table systems within our stackers. So overall outcome of our Gen 3 stacker at this point of moment is 0.1 second per sheet. We are very compact. We are below 30 square meters. So if you in full configuration, so if you would have a look at the stacker, it's really very small. I'm still talking about maintaining the key values of our stackers, or key added values of our stackers, which is definitely the line scan camera system, so the full vision and the correction possibilities. So at this point of moment, we are stacking with an accuracy of about 150 microns at max throughout the complete stack. At 2 stacking tables at the same time, and we exchange the stack in about 3.5 seconds. So what were the challenges going into the developments of the Gen 3 stacker? Where, yeah, let's simplify the hardware, make it lower, smaller, reduce the footprint. Stack stability, is it smart to move the mass? Is it a good solution? We decided that we are not going to move the mass anymore, and we have a stable stacking table. Of course, we needed to improve the cycle time, as mentioned. We wanted to increase the cleanliness level, which is, of course, as you all know, a major part. And of course, no doubt, we wanted to reduce the production costs as well. So what are the outcomes of our latest generation of stacking? Is that we've been able to, of course, as I mentioned, decrease the production costs. We are able to maintain all the vision systems inside. We do not need to stop. We use so-called vision on fly, which means we are making center corrections over each electrode once placing on the stack table. So we have basically no stoppage time in that. We are using a lot of lightweight materials like carbon fiber, like magnesium. It's very configurable, I would say. So the line scan camera system, the cleaning systems, auto splicing technologies for both electrodes, including the separator, are options. So we're able to even reduce the footprint and squeeze it down to a smaller system. We can eliminate one stacking table, or so we can keep it only on one stacking table. So there are a lot of options, and it's very highly configurable system for the market, which basically we have launched by end of last year. Yeah, what I want to mention, whomever would be interested in seeing a very high-speed stacking solution are very welcome to come. Anything what I have mentioned is displayed at our headquarters in Germany, and feel free to contact me, and I'm able to show it to you. We are not doing a lot of marketing because we believe in seeing is believing philosophy. So whomever would like to see and is interested, you are very welcome. So this is how our stack look like as we speak. So we start with the electrode unwinding. In the middle, we have our cut. Of course, we have our cleaning. We have our line scan camera systems, and in the middle, we have our stacking table. So the stacking tables are opposite from each side. The machine is operational from both sides, but the loading happens only from the front side. So we have one stacking table over here where you can see the HMI, and on the other side as well. So the complete system, as I mentioned, is 29 square meters as we speak. All right, and to conclude on the technical part and on our presentation, so what are the main technical features in compared to the market? Of course, the throughput we see, and we want to be very open, around 0.4, 0.5-ish stable performance out of the market. We are able to deliver stacker, which is stacking 0.2 seconds per sheet per table, so much higher speed. Of course, value. We see price dumping on the market. Stackers are getting very, very cheap. Nevertheless, we are aware about that, and we want to conquer the market with the best price for some performance ratio, which we believe is the only way how a well-established German equipment supplier can contribute and win this game on the market. With regards to traceability, I haven't mentioned, but very important, we are fulfilling the highest automotive standards for traceability, including PECML standards. Basically each electrode which is being placed, its picture can be stored, delivered. So yeah, basically 100% traceability throughout all the processes. In terms of inspection, I mean, I haven't been diving into our standard portfolio, but what I can mention for those who are from US, we have a machine which inspect the prints of US dollars. So our vision portfolio is on very high standards, and we basically implemented our highest vision standards into battery machines as well. So we normally use, even in the notcher, in the stacker, down the road, basically in every system, a line scan camera to detect particles and communicate then directly to our CT solution, which we use after stacking, inline CT solution for our lines. And last but not least, the footprint, as mentioned, one of the major cost drivers on the market, and that is why we would like to focus on keeping our lines very compact, that we can save as much dry room costs as we can. So I guess that would be it from my side for today as far as stacking concerned. Thank you very much to everybody for listening. I hope I haven't bored you. I hope you learned something new, and I'm more than happy now to take on some questions. Yeah, if there is anybody would be interested, here are my contact details. Please do not hesitate to reach out. So thank you once again to everybody.